All right, so in this video, we are going over notes 1, and I know it doesn't say here, it's section 6.6. So we left off with 6.5 right before we could do the chapter test. So we're just going to keep moving on, and we're going to talk about the last section in chapter 6, which is 6.6. It's called parallel and perpendicular lines. So by now we know our three different forms of equations. So we have our slope-intercept form, we have standard form, and we have point-slope form. All right, so we're going to kind of build off of that, and we're going to talk about parallel and perpendicular lines. So today we're going to talk about parallel lines. Tomorrow or Thursday, we will talk about perpendicular lines, okay? So today, parallel lines. Parallel lines, there are two specific things about parallel lines. So two lines that are parallel, what does that look like? Well, you want to keep in mind that if you have, let me get a piece of scrap paper here. Right, so let's say this is our graph. And this is our line. Well, what would a parallel line look like? So we need a line that is parallel to this line. Well, a line that is parallel to this line would look like this. All right, it doesn't have to be there. It could be up on the other side. There's many different options here. But one thing that's important is that these two lines never intersect each other. They always run next to each other, but they never actually cross paths at any point in time. Okay? So keep this image in mind today. I'm actually going to keep it right here as we're going through notes and as we write down a few important things. So parallel lines. Parallel lines have the same slope. Well, does that make sense for our graph here? Yes, because they have to have the same increase or the same decrease in their line so that way they never intersect each other. Okay? The other thing that they must have, so they have the same slope, and they have different y-intercepts. Now, if they have the same slope and the same y-intercept, that would mean they're the same line. Well, obviously, they can't be the same line if they are parallel, and they are two different lines. So they need to have the same slope, so that way they increase or decrease at the same rate, or have the same rate of change. Then they also have to have different y-intercepts, so that way they are intersecting our y-axis at two different points. Okay? So let's talk about our two different types of examples. Are the graphs of y equals 2/3 x plus 1 and 2x plus 6 equal to 12 parallel? Well, in order to determine whether they're parallel or not, so it's either a yes or no question, yes, they're parallel, or no, they're not. To answer that question, we have to know whether or not the slopes are the same and whether or not their y-intercepts are different. What is the slope and y-intercept of this first equation? Can we determine that? Yeah, it's already in slope-intercept form. We know that the slope here, let's write this down. Slope is 2/3. And our y-intercept is 1. But do we know the slope and y-intercept of our second equation? Not yet, but we can figure it out. We can rewrite this equation so that way it's in slope-intercept form. So that way it looks like this guy. And we can pick out our slope and y-intercept to determine if they are parallel. So let's solve this equation. All right, so we're going to solve and get y by itself, so that way it's in slope-intercept form. So draw your line down the equal sign. I'm going to go ahead and circle y so I know I'm getting it by itself and getting it alone. So I need to cancel out my 2x on both sides by subtracting. So I get 6y equals negative 2x plus 12. Again, I am trying to get y by itself, so now I need to divide by 6 on both sides. So I get y equals negative 2x divided by 6. Well, negative 2x negative 2 divided by 6 is the same thing as negative 1/3 x. 12 divided by 6 is 2, so plus 2. Now this is my new equation. All right, so now let's determine what our slope and y-intercept are. Well, what's our slope of the second equation? Our slope is going to be negative 1/3, and our y-intercept is going to be 2. I apologize for my dogs. Lay down. So now we have to look at our two slopes and our two y-intercepts to determine, do they have the same slope? And do they have different y-intercepts? So let's look at the slopes. Are the slopes the same? No. So our answer right away, automatically, because they don't have the same slopes, our answer automatically is no, not parallel. And again, it does say explain here, so we do have to say because, and my pen is dying, they have different slopes. Now, I don't care about the y-intercepts if the slopes are different. I only care about the y-intercepts as long as the slopes are the same. So, let's use this same information a little bit differently. Writing equations of parallel lines. So we need to write an equation of the line that contains this point and is parallel to this equation. So the point must be negative 2, 3 and is parallel to y equals 5/2x minus 4. All right, so we know if it's parallel, that takes us back up to here saying slopes are the same. Oh, slopes are the same and y-intercepts are different. So if it has to be parallel to this line, I know my slope has to be 5/2. Greta, stop. Again, my apologies about the dogs. All right. Parallel. Slope has to be the same to this equation because parallel lines have the same slope. Okay? I don't care about what this y-intercept is because I know it has to go through this point. So now I'm going to use this point, which is my x and my y. All right. Now, I have a point and slope. Out of the 3 different types of equations we have slope-intercept form, standard form, and point-slope form. What method shall we use to write an equation with a point and slope? We're going to use point-slope form. So again, a little note off to the side. Point-slope form is y minus y1 equals m times x minus x1. So then I'm just going to plug in accordingly. So I have my x1 and my y1. I'm going to plug them in for x1 and y1. And then I have my slope. So here we go. I get y minus y1. Well, y1 is 3, so we're going to go minus 3 equals m, which is 5/2, parentheses, x minus x1. Well, x1 is negative 2, so I'm going to write plus 2. And we're done. Okay? The question doesn't specify what form the equation has to be. It just has to be an equation. So this counts.